Preparing for MBA exams can be overwhelming with so many concepts and questions to cover. So that is why I have curated this video containing 5 of the most repeated questions in the term and examination along with their answers. Yes, this video is designed to save your time and boost your confidence. How did I make this list? By carefully analyzing the past term and exam papers so that you won't have to start from scratch. You don't have the time to go through this whole video to find out the answers? No problem. Log in to www.anusclassroom.com and purchase the concise revision-friendly answer scripts that I have prepared for these 5 questions. It is ideal for some serious last-minute learning. What do you understand by correlation coefficient? Discuss the different types of association between variables. So, in simple terms, correlation coefficient is like a score which tells us how strongly two things are related. So, the value of this correlation coefficient always falls between -1 and +1. So, in between there is also a 0. So, it is either so the range is between the -1 and +1. So, 0 indicates that there is no relation at all. There is no linear relationship at all between the two variables, which also means that the two variables are not influencing each other in any predictable way. If the number of this correlation coefficient, if it is closer to +1, then that means the variables that we are checking is having a positive correlation, and that also means that if one variable is increasing, then the other also will increase. Like for example, what you can say, the price of petrol and your fruits and vegetables. If the price of petrol goes up, we know that the prices of fruits, vegetables, and such is also going to go up. The reason is because these two variables are positively correlated. Okay. And another example that I can say is the number of years of experience someone has versus the skill level that they possess. So usually we assume that depending on how many years of experience you have, that much skill also will be better for you. Compare a 2-year experienced and a 10 or 15 years experienced person. You expect the 15 years guy to have more skill than the 2 years guy. Correct. On the flip side of the coin is -1, right? So if the correlation coefficient is closer to -1, that is below 0 and closer to -1, if that is the range, then it means that the variables are related but negatively related. That is, if one variable goes up, the other is going to come down, like that. So you can think about the relationship between the price of gold and the number of shares investors might buy, right? If the price of gold is high, then investors will have less money to buy because, they will have less money to buy, or you can say they'll have money only to buy less number of shares. Correct. Like that. Sometimes, as I said, there will not be any correlation at all. That is 0. That means any change in one variable will not, or it doesn't seem to affect the other. Example might be somebody's height and shoe size. Not every tall person has a very big feet, correct? And not everybody short has a small feet either. So that is one example of two variables which are having no correlation at all. So that is -1, 0, and 1. So what happens when the value of this correlation coefficient is exactly -1 or if it is exactly +1, right? We were talking about numbers closer to -1 or closer to +1 or even 0. But what if it is exactly -1? What if it is exactly +1? Then what we have is perfect correlation. Okay, it is called as perfect correlation, which is very rare in the real world. A value of +1 or -1 will mean that every single change in one variable is going to exactly match a similar change in the other. That is like, say for example, if your salary and your skills or your number of experience is perfectly correlated, which it is not, but let us assume it is perfectly correlated, then every 1 year you gain in experience will have a corresponding increase in salary. Okay, so that is a perfect correlation. It almost never happens outside of textbook because real data has errors and also is influenced by outside factors. Finally, in statistics and in regression analysis, you might hear the term called multi-collinearity. Okay, I'll just write it down here. Multi collinearity. Collinearity. Okay, collinearity. Yeah. Multicollinearity, you might hear this term. This is very important for us to understand. This happens when several independent variables are very closely related to each other, and this multicollinearity between variables can mess up our analysis by making it hard to see which variable is truly influencing the outcome. Okay, so to sum up, you can say that the correlation coefficient is definitely a handy tool to measure relationships, and understanding these types of associations always helps us in analyzing and interpreting data effectively. Hey, if you're enjoying this session, take a quick moment to subscribe to Anu's Classroom and turn on notifications so you will never miss an update. Your likes, shares, and even a super thanks or sticker are little boosts of encouragement that help me keep creating and growing this channel. You got any questions, ideas, or suggestions? Drop them in the comments. I love hearing from you and I'm always here to help however I can. Now let's head back. Time series analysis is one of the most powerful methods in use, especially for short term forecasting purposes. So, this is a statement that is given, and we are asked to comment on this statement and also explain the decomposition method. Okay, so time series analysis. It is definitely one of the most widely used tools in forecasting, especially when it comes to short term predictions. The basic idea of a time series analysis is quite simple. We take the historical data and we try to extract patterns so we can understand what might happen next. Like, for example, this whole top five questions, this is done through what you can say a sort of time series analysis only. I took the previous year's question papers, I analyzed the questions, and I am predicting that these questions might repeat in your term and examination because of the frequency in which these concepts were tested, right? So that is time series analysis for you. This is often used in fields like economics, finance, as well as social sciences, where knowing future trends become very important. Now, one of the most common approaches in this time series analysis is the decomposition method. So the decomposition method that we are seeing over here is one of the methods of doing time series analysis. You can think of the decomposition method as breaking a very complex story into chapters so that it becomes easier to understand. But in this case, what we are going to do is we are going to split the data into basically four main components, which are there. First is the trend. Trend shows the long-term movement of variable. It could either be upwards or downwards. For example, a company's annual revenue may steadily grow over the years, right? So that is the first component. Basically, you're decomposing. Okay, so that is the first component. The next component is seasonality. It reflects recurring patterns over regular intervals like monthly, quarterly, or yearly. Like, for instance, say ice cream sales. It rises in summer, it falls in winter due to the seasonal demand, correct? So that is seasonality. That is the second part of the whole data. Then we have cycle. That is the third component. It involves longer term fluctuations that go beyond the regular seasons, like business cycles or economic expansions or recessions. These are cycles. And finally, the fourth component is the randomness or the noise, which covers all the unpredictable variations like, say, sudden market shocks or measurement errors or unforeseen events like COVID-19 that we had. So these are randomness or noise. Now, by separating these components, analysts can better understand the structure of the data, they can spot the trends, and they can develop forecasting models that are more reliable. Okay, so the choice of decomposition technique, whether we have multiple methods like additive methods, technique is there, multiplicative techniques are there. The choice of which decomposition technique to be used depends on the data's characteristics as well as the accuracy that we want in our forecast. Okay. So in short, decomposition turns a complex time series into understandable parts, making short-term forecasting more precise as well as actionable. What do you understand by the term probability theory? Explain the different approaches to probability theory. Probability theory, you know by now, is essentially the mathematics of uncertainty. It helps us quantify the chance of events happening so that we can make informed decisions even when we do not know the outcome of any particular experiment for certain. You can think of it as giving a number to how likely something is going to happen. Now, there are four main approaches to probability theory also that you need to be aware of. There are four major approaches. What are they? First is the axiometric method or the axiometric approach, which was developed by Kolmogorov. I'll write the spelling down. I have a doubt whether I'm pronouncing it properly. Kolmogorov, okay, Kolmogorov. In 1933, he developed this axiomatic approach. Here, probability is defined using a set of rules or axioms. The probability of any event is always between 0 and 1. Okay, according to the axiometric approach. So the probability is always between 0 and 1, and the probability of the entire sample space. Okay, you uh, take the probability of each event or each outcome occurring, you add them all up, you will always get 1. So that is why we are saying the probability of the entire sample space is 1. And for the events that cannot happen at the same time, the probability of either happening is the sum of their individual probabilities. So this approach is very rigorous. It forms the foundation of all our modern probability theory. So that is the first approach, the axiomatic approach. So now the next approach is the frequency approach. This one is quite intuitive. What you do is you estimate the probability as the long run frequency of an event in repeated trials. Like for example, say you're tossing a fair coin thousands of times. About half the time, it will land in heads. This is easy to understand, but it doesn't always work for one-off or rare events. Okay. Then the third approach is subjective approach. Sometimes it so happens that we don't have enough data to calculate the probabilities of events objectively. So in such cases, we rely on personal judgment, or maybe we'll go for some expert opinion to assign probabilities. This is a very common method in fields like finance and all, where analysts will estimate market risk based on their experience. That is the subjective approach. And finally, we have the Bayesian approach, which combines both the prior knowledge that we have about the data or the events as well as the new evidence. So, using Bayes' theorem, we can update our beliefs about the probability of an event whenever a new data comes in. This is very useful when we have some initial information, but we also want to adapt our predictions as more evidence becomes available. So, in short, these four approaches that we just now discussed, what are they? Let us recollect. First approach was the axiometric approach. The second is frequency approach. The third is subjective approach. And the fourth was Bayesian approach. So these four approaches gives us the various flexible ways to handle uncertainty. From the very strict mathematical definitions that we had in the axiometric approach to personal judgment in the subjective approach and all these things, making probability theory a powerful tool in decision making across many fields. All of these approaches to probability. The standard deviation is the most widely used and important measure of variation. We are asked to comment on this statement and also discuss the properties of a good measure of variation. So, standard deviation is arguably the most widely used and the most important measure of variation, of course. Why? Because it tells us how spread out the data points are from the mean, giving us a clear picture of the variability in a data set. This is very crucial, not just for understanding the data, but also for performing statistical analysis, for testing hypotheses, and making decisions under uncertainty. Now, what makes the standard deviation a good measure of variation? The reason is lies in five key properties of standard deviation, which you must always keep in mind. The five key properties. First, it has to be consistent with scale transformations. It is What does it mean to be consistent with scale transformations? It means that if we multiply or maybe say divide all the data points that we have by a constant, then the standard deviation also adjusts accordingly. So This allows comparisons across data sets with different units. Second reason, it is because a good measure of variation will be invariant to location shifts and standard deviation is invariant to location shifts. What does this mean? That it should be invariant to location shifts. What does it mean? It means that if every data point is increased or decreased by the same amount, then also the measure should remain unchanged. This ensures that variability is independent of the central tendency. So in the first point, we said that standard deviation is consistent with scale transformations. If we multiply or divide with a constant, then accordingly standard deviation will also be multiplied or divided with the same constant. Here we are talking about invariance to location shifts. So here we are talking about the addition and subtraction. Okay. Now the third is robustness. That means a good measure should resist the influence of outliers and extreme values. Standard deviation is fairly robust because it accounts for squared deviations, which reduces the impact of extreme variations. Fourth point is because of its additivity. If we divide a data set into non-overlapping groups, then the overall variation should be meaningful in terms of the variation within each group. And standard deviation also satisfies this as well mathematically. Lastly, it should be interpretable. We want to measure what is easy to understand and compare. Using the coefficient of variation, which expresses standard deviation as a percentage of the mean, helps compare the variability across data sets with different scales. So, in short, while standard deviation is powerful and widely used, other measures like, say, range or average deviation or quartile deviation can be useful depending on the context. So understanding these properties helps us choose the right tool for analyzing variability in our data. What do you understand by probability sampling methods? Explain the various types of probability sampling. Probability sampling methods. They are a set of techniques that are used to select samples where every element in a population has a known, okay, has a known non-zero chance of being included. This is important because it reduces bias and allows us to quantify potential errors, making our analysis more reliable. Now, the first and the simplest method of probability sampling is the simple random sampling, SRS for short. Here, every individual has an equal and independent chance of selection. It is easy to understand and unbiased, but it can be hard to implement for very large populations, especially if we don't have a complete list of all the elements. Next type of sampling that I want to touch upon is systematic sampling. So instead of random selection, here we pick, say, every kth element or every nth element from an ordered list. So maybe if you are thinking about, if you visualize all your samples are arranged neatly in a, in a line, then every nth sample, let's say if n value is 10, every 10th sample you take. That is systematic sampling. This is more efficient for large populations, but again, it requires care to avoid any sort of periodic patterns that may bias the sample. The next type of sampling is called stratified sampling. Here the population is divided into subgroups or strata based on key characteristics like, say, age or income or education, depending upon what your population is. And then random samples are drawn from each of the strata. This will ensure that all groups are represented and it often reduces variability compared to our simple or random sampling. The final type of sampling that I want to talk about is cluster sampling. This is also very useful when a population is spread out geographically or it is very hard to access the samples individually. The population in that case will be divided into clusters, and some clusters will be randomly selected, including all the members of those clusters. While it is efficient, again, it can increase variability if clusters are very different from each other, and it may also underrepresent smaller groups. So all of these are the various types of probability sampling that I wanted to touch upon in this video for as part of this question. Now these methods can also be combined or adapted depending on the study's goals. Okay, so the overall sampling is overall this probability sampling is theoretically superior to another method of sampling which is called as the non-probability sampling, but practically sometimes when we look about it, non-probability methods are preferred in specific situations, even though probability sampling methods have this much of plus points.